Hi, world. Welcome to the first ever Yellowstone Volcano Observatory Facebook Live event. We have 3 people here, 2 in person, 1 virtual, also a lovely image on the back wall. I'm Wendy Stovall. I'm the Deputy Scientist in charge for the Yellowstone Volcano Observatory, and my specialty is geology. And
I'm Mike Poland. I'm the scientist in charge of the Yellowstone Volcano Observatory, and my specialty is in geodesy. And Jamie, you want to introduce yourself?
Yeah, I'm Jamie Farrell. I'm a professor of seismology at the University of Utah. We operate the seismic network in Yellowstone National Park, and I'm also the chief seismologist of the Yellowstone Volcano Observatory.
All right, excellent.
yay.
And just so you know a little bit about what YVO is, it's not a physical observatory in the same way that many other places are, like the Hawaiian Volcano Observatory or even the Cascades Volcano Observatory. Instead, it's a consortium of organizations, the United States Geological Survey, the Park Service, the University of Utah, the University of Wyoming, UNAVCO. UNAVCO is a group that runs deformation monitoring stations, and the state geologic surveys in Idaho, Wyoming, and Montana. So it's actually a really nice grouping of scientists that are all focused on better understanding how Yellowstone works.
Yeah.
So with that in mind, we hope you send us your questions. And in the meantime, we're going to get started with a few questions that were previously posted in response to some of the announcements. And the first one we'd like to deal with involves some of the earthquake activity that's happened recently. So we'll leave this to send this over to Jamie to answer. And so, Jamie, the question is, what's up with the earthquake swarms? And can Yellowstone have a really big, over magnitude 6 earthquake? And if so, what would the effects be?
That's a good question. I can tell you right now, so earthquake swarms in Yellowstone are pretty common. We get a lot of earthquake swarms in and around the park. Overall, about half our seismicity in Yellowstone occur as part of earthquake swarms. And it's not just a Yellowstone thing. They're pretty common at all active volcanic systems. We've had some large earthquakes in the past. So the image you're seeing now on the video screen that Wendy's holding up is a seismicity map of Yellowstone. All the red dots are earthquakes that have been located in Yellowstone from 1972 to the current time. All the blue dots are events that we've identified as part of earthquake swarms. So you can see the earthquake swarms happen almost any place that we have seismicity. And on that map, there's a total of about 48,000 earthquakes located on that map. But as far as recent times, last year we had one of the second largest earthquake swarm we've ever recorded in Yellowstone. We call it the Maple Creek Swarm. We located about a little over 2,400 earthquakes in that swarm. It began in June and ended around September, although it had some continuing activity after that. And then again, just this year, we had a continuation of that swarm. It started up again in February, and we located a little over 700 earthquakes in that swarm, and most of them are all really small. In fact, the swarm that's going on that was happening earlier this year, the largest earthquake in that swarm was a magnitude 3.1, and there are no really reports of any of those events being felt. There were felt reports for last year's swarm. Now, to go on to the part of the question about can Yellowstone have a larger earthquake, the answer to that is definitely yes. We have had a couple of earthquakes in the Yellowstone area, larger than magnitude 6. So in 1975, we had a magnitude 6.1 near the Norris Geyser Basin area. It's that circle on that map that she's trying to point to. It's the largest event that's happened inside the park and within the caldera. And then, of course, in 1959, we had the magnitude 7.3 Hebgen Lake earthquake, which is the large star there just west of the park boundary in Montana. And, to answer your question about what kind of effects they would have, both of them had a lot of effects on the park. Then a lot of rock falls that blocked the roads, a lot of changes to the hydrothermal systems, some temporary, some permanent. There was some, as far as the Hebgen Lake event, the magnitude 7.3, there was damage to some of the buildings, namely the a lot of buildings in West Yellowstone, Montana, and the Old Faithful Inn. There might have been some damage from the 1975 event, but the biggest impact, I think, to visitors would be these rock falls and landslides that would block transportation, definitely for a magnitude 6. So hopefully I answered your question.
Okay, great.
Great, thank you, Jamie.
So just so you guys know, if you have questions, please just throw them into the chat, and we will get to them as we can. If for some reason we don't get to all the questions, then we'll try to follow up later as well.
Yeah, we'll try to put some posts together that answer some of the questions we weren't able to get to. So the next question is one I'd like to handle. Someone had asked that they hear we're monitoring the elevation in the caldera, and is it rising? And I've got some plots I can show of that. In fact, yes, we are measuring how the ground deforms in Yellowstone, and the best measures by far are the GPS stations that are scattered throughout the park. There's over a dozen GPS stations that are scattered in various places, including within the caldera, outside the caldera, even outside the Yellowstone system in total. So I'd like to show a plot of some of these GPS data and show you how to interpret them. So this is data from a station near Norris, the Norris Geyser Basin, and we have the east deformation, the north deformation, and the up. And the way you interpret this is in the east plot, if you see it going positive, it means it's moving to the east. The station is actually moving east. And if it goes negative, it means it's moving west. In the north plot, if it goes down, it means it's the station's moving south, and if it goes up, it's moving north. And in the up plot, this is the vertical deformation down here. If it goes down, it means the station's subsiding, and if it goes up, it means the station is uplifting. So what you can see here at Norris is there was an event in about 2014 where the station actually went up to the south and to the east before all of those reversed, and right now Norris is actually in a period of uplift, moving to the south and moving to the east. So that's the way you interpret these GPS plots, and you can get these on the YVO website or many other places. In terms of what's happening in the overall caldera, this is a plot put together by our colleague Christine Puskas from UNAVCO, and she organized a number of GPS sites that are within the caldera, some sites that are sort of on the rim of the caldera outside of it, and then here's Norris. And what you can see here, this is just the vertical plot, is that since 2010, so this is the last 8 years or so, the caldera actually went down, and then it went up. There was inflation, and right now the caldera is subsiding. Outside the caldera, we really don't see much in the way of vertical deformation. It's very, very flat, and that's to be expected. We're sort of outside the range of the active magmatic system. And then Norris has these interesting events where we go uplift, subsidence, uplift. There was a bit of a subsidence event in December. We're now back to uplift. Norris is one of the more dynamic places in the park, perhaps because of all of the water that's coming to the surface there. So yes, we are monitoring deformation. The GPS data are some of the really interesting ways of tracking that. And right now, the caldera is going down, it's subsiding. Norris area is uplifting.
Okay.
So Wendy, you want to take the next question?
Yeah.
This is about, are there signs that Yellowstone will erupt soon? Is it overdue? Will it erupt within the next few years? Randy asks, will it erupt in the next 6 years? And Madeline would like to know, what are the signs that an eruption might occur?
Okay. So this is a question that we get a lot, and the question of whether Yellowstone is overdue is a kind of interesting one. I'm going to show you a map here that shows the hotspot trace. So Yellowstone is a hotspot volcano. You can see its evidence across the Snake River Plain. This is a map that shows the state of Idaho. This is the state of Idaho here. And here is the current Yellowstone volcanic field right up here. And this is the state of Wyoming. And the numbers that you're seeing here are the number of basically millions of years ago that these volcanic centers erupted. Now, if you take into account just back through the last 6 million years, then the average recurrence interval is about 900,000 years, 996,000 years actually. And if you really only looked at the Yellowstone volcanic field, and this is the number that people cite most often, they say it erupts every 600,000 years. Well, that's not actually true. The average of these two intervals between 2.0 and 0.6 and 1.2 and 2.0 is 740,000 years. So it's actually a 740,000 year interval if you take in just those. but you can't really get statistically accurate if you look at only 2 intervals. And the way that it works is this volcanic field there's cycles that it goes through. So it erupts, and it erupts rhyolite lava flows, big rhyolite lava flows, and then it'll erupt in a super eruption, and then more rhyolite lava flows will come in and fill in the caldera. So the super eruption will form a caldera. Here, this is the Yellowstone National Park, and all of the pink stuff is rhyolite lava flows that have erupted since the last super eruption, which was 600,000 years ago. So if that interval is correct, 740,000 years, and it's been 600,000 years since the last one, then we're really 140,000 years away from another eruption. So that's one aspect of it. The other aspect is if it does erupt again, more than likely we would see more of those lava flows. And the lava flows will have an impact inside the park. They're very big. The last one was 70,000 years ago, and it erupted an area that is about the size of Washington, D.C., called the Pitchstone Plateau. And in addition to the lava flows, there were mild explosive eruptions, not putting ash very high up into the atmosphere, but definitely things that would impact the national park area. We're not seeing any signs presently that Yellowstone's doing anything different than it has. We've had lots of indications of all of the seismic swarms and everything. Those have happened since we've been monitoring, and it hasn't erupted yet. So we don't expect that it will erupt anytime soon.
Okay.
Okay.
So let's see, there's a question here from John Graves about what happens when it goes off if we're traveling. Do they ground flights? You want to handle any of the ash aspects?
Yeah, so now that I've covered the it's probably not going to happen aspect, we'll go into the what if aspect. So what if there were a super eruption? Yes, ash would go high up into the atmosphere. It would cover a lot of area. This is a map of the deposits of ash that have occurred from Yellowstone. So the Mesa Falls ash bed was the smallest of the last 3 caldera forming eruptions, and that one actually wasn't a super eruption. Super eruption has to be 1,000 cubic kilometers of ash, and this one was not that big at all. 1,000 cubic kilometers of ash, just so you guys know, would cover the state of Texas to 5 feet thick. So it's kind of a lot. Kind of a lot. Huckleberry Ridge and the Lava Creek ash beds were much larger. And you can see that, yeah, ash is going to fall out here, but in the distal part, like really far out, it's only a couple millimeters thick. It's going to make it pretty annoying to drive around. And but closer into the park, there would be more ash. So yes, airplanes would be grounded during the eruption, but not after. Right.
Okay.
Okay.
Jamie, I think we've got one for you. There's a question about how earthquakes affect the geyser basins and other geothermal features.
Yeah, in fact, that's a good question. I think it's coming from Yellowstone National Park, actually.
Yeah.
So what happens is, and actually, to premise this, I would say that geyser basins, active geyser basins, actually need earthquakes to stay alive. And the reason for that is, these hydrothermal fluids are moving through the ground in these, small fractures in this network of fractures, and that's how the water is getting from deep up to the surface. And you need earthquakes to kind of shake that up and not only create those fractures, but to keep them open, because these hydrothermal systems, this hydrothermal water is heavy with minerals that deposit as they move through these systems, and they tend to clog themselves up. And when you get these large ground shaking from earthquakes, you break that up and allow these things to happen. And what we've seen in the past is when you have the earthquakes can affect these things in many ways, but 2 of the main ways that I'll talk about now is one, just the fact that the ground shaking causes a change in the stress field, and these hydrothermal systems are almost stressed, ready to go. They're almost ready to erupt all the time, and they just need this little push from these seismic waves as they travel through to cause them to erupt. And for example, when we had this big earthquake in 2002 in Alaska, the Denali earthquake, when those seismic waves reached Yellowstone, it caused all these features to erupt all at once as those big seismic waves pass through. And those tend to be temporary changes. Now, there can be permanent changes as well. If you have a big earthquake that actually causes new fractures or closes up old fractures, a previous active system could die out or change from being a geyser to a fumarole, or a new system can pop up. You can have a new geyser, or you can have a system that used to be just a hot spring that could now start geysering. So there could be a number of different changes from earthquakes, both from just new fractures opening up, or just changes in the stress from that shaking from seismic waves passing through.
Okay, thanks, Jamie. We have another question from Larry and Karen Brown. Is the bottom of Yellowstone Lake still rising? And this is one I'd like to address because it's pretty neat. There was a report some time ago of sort of a dome on the floor of Yellowstone Lake based on some mapping of the lake bathymetry. And the suggestion was that there had been some buildup of pressure beneath the lake surface. That was never known to be actually actively rising because we didn't have measurements of deformation of the lake floor. But what's happening right now in the park, actually, and over the last couple of years, is some very cool research, a project called HDY Lake, which is focused on understanding the dynamics of Yellowstone Lake, including looking at the hydrothermal systems. There are hydrothermal systems that almost look like the sorts of big spires and hydrothermal vents you see at mid-ocean ridges on the floor of Yellowstone Lake. It's a very active hydrothermal system, quite a hot one as well. And they are putting pressure sensors and seismometers on the floor of the lake to detect what kind of activity might be happening there. So we actually expect to have some pretty neat new results about what's happening on the floor of Yellowstone Lake in the next few months to years. All right, what else do we have? Let's see. How about can we describe some of the different ways that you monitor Yellowstone and what they tell us about the ongoing activity? This is from Katja Kraft.
Yeah, so we monitor Yellowstone in lots of different ways. There's GPS, which Mike has touched on a bit, and there are permanent stations that are out there. So GPS sensors, it's kind of like the sophisticated version of what's in your car or on your phone. And there are sensors that sit out in the field. They're there all the time. And they measure things that are going up and down and north and south and east and west, just like Mike showed in the plots earlier. And those measurements come in via satellite to our computer systems. And then there's also, this is
by the way, a map of all of the GPS stations we have in the park. There's various types of stations, and they're scattered all over the region.
Yep. And then we have seismometers, which is Jamie's forte. And this is a map of all of the seismometers in the park. And there's different types of seismometers that are out there. And they measure earthquakes that are coming through. And earthquakes tell us lots of things. Jamie's touched on many points right now, but one of the other things that earthquakes do, and maybe after this question we'll go into that, is that they can tell us what's going on deep in the system. So seismic tomography is used to make a map of the subsurface, and Jamie can probably talk a little bit more to this in just a minute. We also have heat sensors, temperature sensors at Norris Geyser Basin because it's one of the hottest areas of the park, and there are many geysers that erupt there. It's been the site of hydrothermal explosions in the past, and hydrothermal explosions are second to earthquakes in the most hazardous type of volcanic activity that could occur in the park. They're basically steam and rock explosions that would eject rocks out at a pretty high velocity and could hurt people in the area if they were to occur. That's happened in Norris in the past. It's happened in Biscuit Basin. We know that it's happened in Mary's Bay at the north end of Yellowstone National Park, which is the largest hydrothermal explosion in the world. It's in the lake. It's 2 miles across. So let's see what else we monitor for. We monitor.
There's some geochemistry of the water.
Geochemistry
that gets done.
Yep.
I'm looking at major river systems.
Yeah, and those tell us the chemical components of the rocks, and they can tell us about magma that's underground. And then we have strain meters, which we wrote a YCC Yellowstone Caldera Chronicles article about, and they measure the amount of strain that is.
Yeah, how the rock is deforming.
Yep. And then there's tilt meters. You want to talk a little bit about that?
Well, and tilt meters are pretty neat instruments that are actually measuring the tilt of the ground surface. It's a bit ambiguous sometimes because if the ground is tilting like this, you don't know whether it's because this side of the ground is uplifting or this side of the ground is sinking. But tilt meters are very good over short time scales for looking at subtle changes. Over long time scales, they tend to drift. The instruments sort of are unsettled, which is why we prefer to look at GPS for long time series deformation.
Yeah.
And we also do a lot of spot measurements as well,
Yeah.
sampling of springs to look at their geochemistry, the gases, or the water chemistry. And hopefully in the next year or two, we'll get a permanent gas station installed. We've done some spot measurements over the course of a few days to weeks to even a few months of gas. Unfortunately, we haven't been able to install a system that can operate year-round in Yellowstone, but I think we're going to be able to get one online here in the next year or two.
Yeah.
And those data will be on the website when we get it.
Yeah, all of the data that we collect is available on our website, USGS, or volcanoes.usgs.gov/observatory/YVO. If you click on monitoring, then you'll see our monitoring map, and you can access all of our data.
And Jamie, do you want to talk just real quickly about this tomography image that you were a part of creating?
Sure. So one good thing that earthquakes are good for is imaging subsurface of the Earth. And the way we do that, if any of you guys know, it's the exact same technique they use to image the body. For example, if you get a CAT scan of your body or an MRI, they're using the same technique, only we use earthquakes. And what we do is we have this whole network of seismometers in and around Yellowstone that they showed earlier. And then we have all these earthquakes that are happening, and we know exactly when and where those earthquakes are occurring because we can locate them. And what we do is we measure the time it takes for those seismic waves to go from that earthquake at depth up to one of our stations on the surface. And we do this for many, many earthquakes all around Yellowstone, and we do that, and we record those at all of our seismic stations that we can throughout the park. And what we can tell is you can tell places where the seismic waves are traveling faster or slower, right? And because when seismic waves travel through hot or partially molten material, they slow down and they travel slower through that material. So we can do this for many earthquakes and many seismic stations throughout time, and we can basically map out where these slow seismic velocity areas are, and we can say those are where the magma reservoir or the area of partial melt is. And what you can see on this image is this image that we've come up with showing what we think is what we call the complete plumbing system of Yellowstone, of the Yellowstone volcano. And what we found is that basically we have this what we call the upper crustal magma reservoir, which is that top kind of reddish orange body up there, and then below that, on the lower crust, we have this larger magma reservoir, which is labeled on there as basaltic partial melt. And then below that, you get into the mantle, and you have the hot spot or the plume coming up from deep in the mantle, which is feeding heat and energy up to Yellowstone. But there's kind of a misconception of what a magma reservoir is beneath the volcanic system. And just to give you an idea, these aren't just giant voids in the earth that's full of magma. These are areas that we call partial melt. And I like to tell people it's kind of like a sponge, right? So if you have a sponge, you have most of the material in that sponge is solid, and you have these pore spaces in there that, in the case of a sponge, gets filled up with water. So similar to a magma reservoir, most of the material in there is solid, although it's hot. But you might have pore spaces in there that could be filled with magma. Now that upper reservoir, we estimate to be anywhere from like 10 to 15% melt. And then that lower reservoir would even be less, maybe 2 to 5% melt. And the rest of that is probably solid material, although it's still hot.
Yeah, thanks, Jim. And there's actually some questions coming in that are sort of relevant to this kind of thing. Let's see, I just had them here. Well, there were some questions about the depth of magma in places like Norris and so forth. The upper magma chamber is somewhere in the order of about 5 kilometers down, the top of that reservoir. So we're talking somewhere in the neighborhood of 3 miles to the surface before you start to get to this mushy zone that Jamie was talking about as being the magma reservoir. And remember, it's not a void, a big balloon of magma. It's a mushy zone that's only a few percent melt. There's some questions coming in about drilling from Janie Shoup and Lenny Sinceri. What do you think about geothermal drilling, and would the park be affected by changes in drilling? Well, some of these questions may come from a NASA or a Jet Propulsion Laboratory report that was released some months ago. And we tried to address this in the FAQs on our website. There's no plan to do any drilling at Yellowstone. This was just sort of a concept that was put forward, more kind of a thought exercise and some calculations. There's no plan to do any drilling at Yellowstone, and I can't imagine that it would ever be allowed, given that it's a national park. And it wouldn't actually have the intended effects on trying to cool the magma body anyway. So it's not really even a good idea. And it would have the potential drawbacks of affecting all of the wonderful natural features that we go to Yellowstone to see. In other places in the world where geothermal wells have been drilled near geysers and thermal activity, it's actually muted that activity. So it's not something that's likely to happen at Yellowstone. There's also some questions coming in from Stephen and Randy about animal behavior, right, which is something we see a lot about in terms of questions. I'm not aware of any reports that actually say animal behavior changed prior to an eruption. There was a YouTube video, I think a few years ago, that showed like animals are running out of the park or something like that.
Yeah, but they were actually running in the park.
Yeah. They were actually running into the park, not out, which was sort of funny.
Yeah, that happens. That happens where things get turned around
Apparently the animals get turned around too.
They do.
There's a question from Anne. Are there other places on Earth that are like Yellowstone, and do they behave in the same way? And in fact, yes, there's many, many caldera systems around the world. Rabaul in Papua New Guinea, Campi Flegrei in Italy, Long Valley caldera in Eastern California, the Toba system in Indonesia, there are Taupo in New Zealand. There's a great many of them. They often have similar characters in that they sort of have an upward bulge in the center of the caldera, a thing we call a resurgent dome, which happens shortly after the caldera forms, that you get this sort of upward doming. And some of them are very active, and some of them still experience eruptions. Rabaul, I think, is erupting either right now or recently. Campi Flegrei last had eruption in 1538. Toba erupted 74,000 years ago in an eruption that was larger than Yellowstone's most recent big explosion. Yeah. So yeah, there are calderas around the world, and we can learn a lot about Yellowstone by studying those other calderas, and we can learn a lot about those other calderas by studying Yellowstone. So looking at these big volcanic systems is sort of a theme among some volcanologists. Let's see. We got some question about, Jamie, does an increase in seismic activity mean an eruption is imminent? This from Leah Dingman. St. Helens was a bit of a surprise, so how are we able to fine-tune our eruption predictions today?
So this is a common question we get. Just because we have a big seismic swarm going on, does that mean Yellowstone's going to erupt? The answer is definitely no. And there are typically, luckily for volcanic eruptions, there typically is precursory activity to volcanic eruptions, seismic activity being one of those. Other things are ground deformation that we talked about earlier, and changes in the hydrothermal system or increased gas output, and we monitor for these things for that purpose. And what I like to tell people is just because you have an increase in seismicity doesn't necessarily mean that there's magma moving through the crust getting ready to erupt. It's only one of the precursory signals, and if you're only seeing changes in seismicity, that probably doesn't mean that there's an eruption happening. It likely doesn't mean there's an eruption going to happen. If you start seeing these changes in all of these things, and they're all pointing to the same thing, then you might want to look into it more and get a better idea of what's going on. But if all we're seeing right now is changes in the seismicity rate, it likely does not mean that there's magma moving through the shallow crust. And I'd like to combine this. There's another question on there that says, if it was to blow, how much time would people have in advance to get out of the area? And I think this pertains to what we're talking about now, these precursory signals. And other volcanic events have been predicted pretty well that these things are going to erupt. I would say, as far as Mount St. Helens, I don't think it was much of a surprise. There was a lot of there's a lot of warning to that volcano, Pinatubo. There was a lot of warning, and they knew it was going to erupt, and they got people out of there in time. As far as Yellowstone and these large caldera systems, we've never really witnessed one of these things with any instrumentation or in human life, so we don't know exactly how these behave when they start ramping up to an eruption. But if we take these smaller eruptions, relatively smaller eruptions, and kind of scale them up to Yellowstone, we do believe that there would be precursory activity before an eruption, that we would know something was happening. But I don't think I can tell you how much time we would have to know, if this thing was going to erupt, whether that could be days, weeks, months. I can't tell you that right now, just because we've never seen that.
Yeah, I think there's an important aspect too about what constitutes background activity. And volcanoes are kind of like people; they have personalities. Some volcanoes are very, very active, and they have a lot of background activity. So at a place like Yellowstone, there's thousands of earthquakes a year. If you put that same kind of activity at a place like Mount Rainier, we would be thinking this is abnormal. But in a place like Yellowstone, the background is that it's a very active place because of all of the fluids moving around in the subsurface, and it's sitting in an environment that's very prone to earthquake activity. Yeah. So what constitutes background in one place and would be an alarming increase in seismicity or deformation or other indicators in one place is not going to be the same for what you see in another.
Yeah, we're really looking at relative changes in these things. So how has it changed compared to what's been happening previously or the long term, or the long-term average?
Yeah, that's a good point. We have a question from Michael Knight about, will I be safe in Yellowstone? Stay on the boardwalks.
Yeah, that is actually true. In Yellowstone National Park, and the park can probably chime in here, is the most dangerous thing is walking off the boardwalk and falling in a hot spring.
But don't
do that.
Yeah. It will ruin your whole day. But there's a lot of folks that worry about visiting the park because maybe there's an earthquake swarm or something like that. And there's nothing different today than there was yesterday or a month ago or a year ago or 10 years ago, right, in terms of our concern of a potential eruption. So absolutely, you should go enjoy Yellowstone. We try to go as often as we can. Yeah. It's an amazing, fantastic place. I wanted to address too, it looks like Brittany Paddock's 6th grade science class has chimed in with a couple of questions. When we think Yellowstone will erupt again, like a big explosion, and how much ash would be released. And this sort of gets back to what Wendy was addressing in the very beginning of the...
Yeah, so we really don't even know if the Yellowstone Plateau volcanic field as it is now will ever erupt in a super eruption again. It's gone through three caldera forming cycles. It could mean that it's done. We do know that there's magma under the ground. We know that there's basaltic magma coming in and sitting underneath the larger rhyolite body. This is the basaltic magma. When the Yellowstone volcanic field is done, we will see eruptions kind of like the ones that are in Hawaii at the surface and inside the caldera. We'll know that it's done then. The volcanic field that is a little bit to the west of Yellowstone, the High C volcanic field, there's been, that was the one that erupted just before this Yellowstone volcanic field. And there have been basaltic eruptions in that. So that's kind of the next stage in the cycle. So
the basalt sort of squirts through up to the surface.
Yeah, and the reason why it can get up to the surface is because the rhyolite body, that spongy body of partial melt, isn't sitting there blocking the basalt to get up to the surface. But right now it's preventing it from getting there. So it's supplying heat, but there's no sign that it's going to erupt. We're not sure if it will. And the ash will, depending on the size of the next super eruption, which may be hundreds of thousands of years, if not millions of years away, much further to the west than we are currently seeing activity now. Who knows if people will be here. But yeah, ash will, if the next super eruption from that system will send ash into the atmosphere, and yeah, it'll be a nuisance for people thousands of miles away, but it won't be life ending.
One question I'd like to grab here, does the slow slip event, Larry is asking, the slow slip event on the west coast affect what's happening in Yellowstone? So slow slip is occurring on the boundary of the tectonic plates that are intersecting off the coast of Oregon and Washington, or one plate is diving beneath another. And when that occurs, you can get these very large megathrust earthquake, magnitude 9 style earthquakes. But there are also every, I think, 14 or 15 months, there's a 2-week period where the plate sort of slides a bit. And we call those slow earthquakes because they're smeared out over this couple-week period. If it happened all at once, it'd be a magnitude 6 or 7 earthquake. Those don't have any effect on Yellowstone that we know of. And it raises kind of a bigger question about triggering. And can big earthquakes trigger eruptions at Yellowstone? And Jamie talked earlier about how seismic waves from large earthquakes elsewhere in the world can cause some changes, for example, in the thermal activity and geyser activity. But what I like to think of is, the last eruption of lava getting to the surface at Yellowstone was 70,000 years ago. How many magnitude 9 earthquakes have happened off the coast of Oregon and Washington in the last 70,000 years?
Lots.
Dozens.
We don't know.
And none of those triggered an eruption of Yellowstone. So the question of whether or not eruptions can be triggered by earthquakes is one that's very active in the literature right now. There's statistical tests and observations that suggest there are effects, like the ones Jamie mentioned. But it's difficult to really put your finger on whether or not there are effects. Statistically for Yellowstone, since it hasn't erupted in 70,000 years, and there was a magnitude 7.3 right next to Yellowstone in 1959, it doesn't appear that the system is primed enough for any kind of big earthquake, even nearby, to do much damage.
So we're about 5 minutes over what we said we were going to do, which is great. That means that you guys are interested, and we're really enjoying talking to you.
We're having fun.
Yeah, I think we're going to take one last question, and after this, we will follow up by, well, we'll do the question. So we have a question that came in from Matthew, and he was wondering whether, he said that it seems people know more about Yellowstone than, say, we did in the 1980s. And he's wondering that corresponding with that, it seems like there's more people, YouTubers and tabloids and stuff, that are starting to also chime in about what's going on at Yellowstone. So I'm going to use this opportunity to talk about this. So we do get lots of questions, and we love getting the questions because we love. We have no viewers now, but we are back.
Well, we can at least record this and play it back later. So
yeah,
Wendy was going to answer a question about all the information that's out there.
Yeah. Yeah.
So starting over for the two people that just that joined back. Sorry about that, technical difficulties.
Yeah. So technical difficulties.
Not a conspiracy.
At a very interesting time. We were just about to talk about the amount of information that we have now about Yellowstone versus what we knew in the past, and say, well, just how far we've come in the past 30 years, 50 years or so. And then also, why are there so many other people out there that seem like they know a lot about Yellowstone? So I think there's a couple of things. One is that, yes, we do know a lot more about Yellowstone. And there's been lots more instruments, technology advances, right? So technology is moving forward, and the way that we monitor Yellowstone is moving forward, and it's becoming more sophisticated. And we have learned a lot. There's a lot more researchers involved in pushing out information about Yellowstone. So we're active in doing that, and we do love to share information about Yellowstone. The other thing that's happened is the internet has been born. So since 1980, hey, we have the internet. We didn't have the internet in 1980. And because of that, there's new and different ways of sharing and getting information. And along with the advances in the internet have become more advances in internet technology and communications technology. And hey, we couldn't have done this Facebook Live event. We would be watching us as in an interview, a scripted interview on a news channel instead of an unscripted, technically challenged Facebook Live event. So we see lots of people coming to us scared because they've seen information that's been promoted by people out there who claim to be experts in Yellowstone. We can't do anything to convince you that we actually are the experts in Yellowstone. So we just hope that you'll trust us. Look, we're people. As Mike was saying earlier, if you were our neighbor, you wouldn't know any different. We just are like normal people, and we're not hiding anything.
Yeah, I don't take a black helicopter when I go to Yellowstone. I drive like everyone else.
I wish I had an invisible airplane though. That would be cool.
But I think that the point is we'd love to, if you have questions, please ask them. We'll try to answer some of the questions that we weren't able to get to today in a Facebook post. And we have an email account as well.
Yes.
It's
YVO Web Team, all one word, at USGS.gov.
And I think you'll find that, I mean, friends of mine that know me know that I love talking endlessly, especially about volcanoes. Yeah. Thanks for the endorsement. We love talking about volcanoes. And so if you have a question, we'd love to try to help you understand more. And we can even maybe in the future do some podcasts on how to access the data yourself. Because a lot of these data are out there as solid numbers. You don't have to rely on plots that we provide you or that are provided by UNAVCO or other places. You can actually get the data, download it, look at the numbers yourself, and sort of teach yourself. So that's a really cool aspect of what the internet brings, is this availability of data. Mm-hmm. It's sort of a horrible thing to say it's an explosion of data, but it is,
but
really.
But there you go.
Yeah, so we hope that if you have questions, you'll ask, and we hope to be able to provide more information to you in the future, both online as part of our Caldera Chronicles, which is our weekly series of information about Yellowstone posted to our website every Monday. And if you have a question, please write in either through Facebook or through our email account, and we'll do our best to answer your questions.
Yeah, and if we didn't get to your question today, then we will follow up with answers to your questions in another post. And
if it seems like there's interest in doing this again, we can do it again.
We will.
Yeah,
yes.
Especially if there's interesting stuff to talk about, like earthquake swarms and deformation, and perhaps some of the research on Yellowstone Lake, or after the summer field season, we get some more results. So
yeah.
So anyway, thanks everyone. Appreciate you stopping by. Hope you found it interesting, and
thanks for tuning back in after we went out there at an inopportune time.
Yeah. Accident. And yeah, hope to see you around Yellowstone. Take care.
Bye.